This podcast is on using multiple regression analysis to forecast election results. This tool has been used for the past 45 years, from President Reagan all the way through to President Biden, to effectively forecast elections, not only in the United States, but also in many countries around the world. Election forecasting will introduce us to time series data sets as well, which brings the autocorrelation regression assumption to center stage. This is simply a neat application of regression analysis, and I'm stoked to tell you about it. The beginning of this enterprise, inspired in part by economic forecasting models, was in the late 1970s. Lee Siegelman, a political science professor then at the University of Kentucky, and later at George Washington University, and he became the editor of the American Political Science Review for a while, published the first election forecasting article, Presidential Popularity and Presidential Elections, in the peer-reviewed journal Public Opinion Quarterly in 1979. On the top left of this slide, we have Siegelman's data and equation. For the last Gallup poll during the election campaign, back then Gallup would end its polling months in advance of the actual election date, is used to create a small regression model where the dependent variable is incumbent party candidate vote share and the independent variable is presidential approval. As you can see, as I circle with my cursor, the slope coefficient for presidential approval is more than twice its standard error, thus is statistically significant. And the r squared, if we square the Pearson correlation, that gives us an r squared of 0.54. Now that's not bad for an r squared for any model, but it could be higher, and it does need to be higher for there to be effective forecasting models, which I will discuss in a little bit. Michael Lewis Beck and Tom Rice from the University of Iowa made advancements on the Siegelman model and published the article Presidential Popularity and Presidential Vote, also in Public Opinion Quarterly, in 1982. Their regression model is on the top right of this slide, right here. The modification that they made is to take the presidential election poll from Gallup in June of the election year, so that the estimate is free from the bias of the general election campaign. Recall that Siegelman would take the last Gallup poll, which could have been right before the election. So the Lewis, Beck, and Rice innovation is free from the bias, again, of the general election campaign, it being in June. And the r squared of this model is higher, 0.85. That's solidly high. And the regression line in the scatter plot at the bottom of the page shows that the data points are very close to the line. It might be kind of hard to read the years, but the years that are listed are the ones in the data set. There aren't very many data points, 6 data points. But the data points are very close to the actual regression line. The data set itself is of incumbents running for re-election from 1948 until 1980. So, of course, not all incumbents were eligible to run for re-election. And one chose not to run for re-election, Lyndon Johnson, in 1968. So after these initial forays into the world of election forecasting, there came to be a veritable industry of forecasters who took up the cause to create innovative forecasting models for many countries around the globe. We don't have time to go into all of these forecasts, but I do want to explain generally what makes a good forecast and look at an example of a forecasting model, a modern forecasting model. So, what makes a good election forecast? There are 3 primary elements to it. So I'll pair this discussion with meteorology, hence the weather map at the bottom of this slide, since election forecasting and meteorology share similar frameworks. First, a good forecast arises from good theory. I'll show you what I mean by bad theory in a moment, But for now, a good election forecasting model will take as its inspiration solid voting behavior theory, such as voters voting for those politicians whom they approve personally, and for good policy performance as well. The parallel to this good theory in meteorology is utilizing theories of air mass movements, temperature gradients affecting precipitation bands, and patterns of monsoonal outflows in the western U.S. in order to make accurate weather forecasts. Good theories, in short, help us to select appropriate variables for our forecasting models. A second element to a good forecast are data that have sufficient lead time to make a meaningful forecast. For example, a well-done public opinion poll the week prior to the election may be relatively accurate compared to one done several months prior, but its immediacy to the presidential election makes the forecast itself be trivial. The meteorological equivalent is a forecast of a rainy day mere minutes prior to the actual rain taking place. Of course, meteorological data go back in time, and one can make forecasts over several days, the 7 to 10 day forecast, and that has varying degrees of accuracy, but at least is more of a forecast. A final element to a good forecast is the model should have sufficient ability to explain variation in the dependent variable. In the case of election forecasting, we're normally speaking of vote share for the incumbent candidate or incumbent party candidate. Our typical measure for explaining variation is r-squared. Ideally, we would like an r-squared that is close to or above 0.70, or 70% of the variation explained in the dependent variable. And in the world of meteorology, the variation that we're trying to explain is the probability of precipitation, or the probability of a heat wave, probability of a blizzard, or high winds or thunderstorms. Now, what makes for a bad election forecast? There are any number of these kind of parlor games that are played in the world of forecasting, which aren't really based on data, but are based on hunches, intuition, and sometimes just dumb luck. So an example of this ignorance forecast comes from the world of baseball, and it's called the World Series rule. Someone noticed that there was a correlation between the winning team and the winning league in the World Series and a particular party and its performance in the presidential election. This rule worked well for a while, but recently it's gone awry. The forecast was simple. If the American League team won the World Series in October, then the Republican candidate would win the presidential election a month later. Why? Well, there's no really good reason other than this worked. Although, if you were to stretch the bounds of credulity, it could go like this. The New York Yankees, who have won the World Series a record 29 times, are also the richest franchise in baseball. And to the extent that the Republican Party favors big business and the wealthy, then that aligns with perceptions of the American League powerhouse, the Yankees. But there's no real voting behavior rule here. It's just coincidence. World Series team winning, presidential candidate winning. Although it's been somewhat successful over time, as you can see, 62% success rate. Now, if we put up the chart for the World Series rule, and this is all the World Series up to the present one, 2020. And look at the winner, the winning candidate, and whether or not there was a correct prediction, so the no's and the yeses. You can see there are times when the rule goes on a winning streak, like a baseball team. So if we go down to 1952, if I can get my cursor to work, And from 52 all the way through to 1976, the World Series rule correctly forecasted the presidential election winner. And a couple other winning streaks here. A smaller one from 2000 until 2012, 4 in a row. And then from 1920 through 1928, 3 in a row. Of course, you can go on losing streaks as well. 1908, 1912, and 1916. No, didn't forecast it correctly. So for all those perfect forecasts and winning streaks, if we look at all the other years, there would be 18 other World Series to consider. In those years of non-streak winners, the rule worked 7 times out of 18, which is a 39% success rate. So if you dig back through the various standings, you'd have to go back to the 1913 New York Yankees to find a Yankees team that won only 39% of its games, or a really bad team. In other words, I don't think you would want to rely on the World Series rule for your election prognostication. That's a bad forecast. Here's a better one, a good forecast. And this one is actually worked within 2.6 percentage points of the popular vote in the last 19 presidential elections since 1948. It's a political economy model by Michael Lewis Beck and Charles Tien. Lewis Beck, of course, is from University of Iowa, and Tien is a professor at the City University of New York. And this forecasting model is very simple. As you can see, presidential vote is a function of the popularity of the president and economic growth. So I'll talk about this for a little bit. The idea is to try to explain variation in the two-party vote share of the national popular vote for the president's party. So that means that we're going to use the two major parties, Democrats and Republicans, combine their vote totals and find the percentage vote share for the president's party's candidate. That would either be the incumbent president, or it would be the standard bearer for the president's party, should the president be term limited or choose not to run for re-election. The other independent variable is gross national product growth, or GNP growth, in the first 2 quarters of the election year. I realize I didn't define the political popularity variable very well. This is the presidential job approval rating in the July Gallup public opinion poll. So it's simply a question, do you approve of the president's performance? And it's a yes or no, so we just figure out the percentage of the respondents who approved of the president's performance. So these elements of a good forecast that I mentioned earlier are certainly present in this model. There's good theory, reward and punishment type theory, to use the phrase put forth by the Harvard political scientist V.O. Keyes some 60 years ago. Voters reward and punish politicians in a democracy. They reward politicians who perform well and punish those who do not perform well. So the presidential approval rating catches those particular sentiments. And even if the president is not running for re-election, that would apply to the president's party's candidate for the presidential election. The state of the economy is also key to understanding voter choice. Again, a reward-punishment framework fits well here. A well-performing economy reflects well on those politicians in charge, especially the president, while a sputtering economy would not be looked upon favorably by voters. So there's theory here, unlike with the World Series rule. There's a lot of lead time in these data as well. The economic data are generally available in July at some point, as is the approval rating from Gallup. So the forecast can be issued in early to mid-August, a full 3 months ahead of Election Day. Whereas 2020 kind of changed the game a little bit, if you will, because of the presence of mail-in voting, absentee voting. So the election date was a bit of a moving target, but the forecast still came a good month and a half prior to those early cast ballots. And final consideration is the model performance. How did it perform? Performed rather well. If we look at the slope coefficients for the 2016 election forecast, one of the best of the forecasts, you can see that slope coefficients are signed positively, which we would expect. The more popular the president in July, the higher the popular vote for the president party's candidate in November. And the greater the economic growth, as seen, GNP growth, in the first 2 quarters of the election year, the more that translates into vote share for the president party's candidate. These are T ratios in parentheses, so statistical significance for each of these independent variables and for the y-intercept for that matter. The R-squared is above that 0.70 threshold that I suggested would be important for a forecasting model. Low error in forecasts. And want to introduce you to something called the Durbin-Watson statistic. So in these forecasts, the data sets are time series data sets, which means that the cases are not like geographic areas or individuals, but they're time points. So the 1948 election, the 1952 election, the 1956 election, all the way through to the current election for which we have data. And that would be 2016 for the 2020 election forecast. So each case is a point in time. Now, I've mentioned before that autocorrelation is really a time series problem. And autocorrelation is where the errors in consecutive observations are highly related to each other. And that can happen in time series data because conditions can be relatively similar in relatively close time points. So it's possible for there to be autocorrelation, and that would bias the standard errors. It would lower the standard errors and thus increase the t-statistics and thus increase the likelihood that you would reject the null hypothesis when in fact you should be accepting the null hypothesis. In other words, type 1 error increases when you have autocorrelation. The appropriate statistic to try to figure out whether or not there's autocorrelation is something called the Durbin-Watson statistic, invented by economists Durbin and Watson. And the idea is to try to measure autocorrelation if possible. And won't go into the formula, but suffice it to say that a Durbin-Watson that is relatively close to 2, and accounting for the number of independent variables in the regression model and the sample size, the closer that the Durbin-Watson is to 2, the less likely it is that autocorrelation is present. So 2.36 is close enough to 2 where we can rule out autocorrelation in this particular model. And the sample size is still pretty small. We can invoke the central limit theorem, for instance. 17 cases. So what do we do with all of this stuff? How do we use the equation? Well, you take the y-intercept, you take the slope coefficient for popularity and the slope coefficient for growth, then you plug in numbers for 2016, and we try to make a forecast. So President Obama's popularity was 51% in the Gallup poll in July, and growth was relatively weak, 0.2% in the first and second quarters of 2016. So you plug these numbers in, you solve the equation, and you get a forecasted vote for Hillary Clinton, the Democratic Party candidate in 2016, Barack Obama's heir apparent, with Obama being term limited, of course. 51.1% is the forecasted vote for Mrs. Clinton. And the actual vote, two-party, remember this is two-party popular vote, was 51% for Clinton. So the forecast was just 0.1% off, which is about as close to a perfect forecast as you're going to find. Thus, the best of forecasting times would have been that 2016 election. Of course, this popular vote margin was not enough for Clinton to win the Electoral College. And of course, the quirks of the Electoral College were exploited by her opponent, Donald Trump. And so it wasn't good enough for Clinton to win the election. Trump, of course, won. Nevertheless, the forecast for the popular vote, which correlates to the Electoral College at an overwhelming rate of 0.96, the Pearson correlation between popular vote and Electoral College vote is 0.96, during the time frame of these forecasting models, 1948 to 2016. So normally the popular vote forecast will track very well the Electoral College results. So 2016 was a fluke. And it certainly is a fluke compared to the most recent presidential election in 2020. So we see that the forecast itself, based upon this model here, same model from Lewis, Beck, and Tien, you can see almost exactly the same statistics resulting with an extra case, the 2016 election. Still statistically significant independent variables, positive slopes, again, theoretically, the expected direction. So the forecasted vote for Trump would be with historically low approval rating of 41%, and the pandemic influenced economic depression of minus 4.14% in GNP growth in first two quarters of 2020, historically low. The forecasted vote for President Trump was 43.3%, which is a very, very low number for any incumbent politician to receive. These are Jimmy Carter type numbers from the 1980 presidential election, when he ran for re-election, was trounced by Ronald Reagan. The actual vote for Trump, popular vote, two-party popular vote, was 47.7%. Oops. Skip ahead, 47.7%. So the model was off by a good 4.4%. And that's one of the elections where the model really did not forecast quite close to the actual popular vote result. But it did get right the fact that Trump lost the election and Joe Biden won the election. It was just off by one of the largest margins in the dataset's history. Now let's look at this chart. This is the accuracy of the Lewis, Beck, and Tien forecasting model and whether or not it forecasted the correct result. And you can see that it too went on a winning streak from 1980 all the way through 2020, correctly forecasting the popular vote winner. Even the 2000 election, recall that Al Gore won the popular vote by about 600,000 votes cast, by a whisper, in other words, out of roughly 105 million votes cast, but still forecasted to win that popular vote and did so, but again, did not win the Electoral College. George W. Bush won the Electoral College. So those are kind of quirky results. On the whole, this political economy forecasting model, as I said, gets within about 2.5 percentage points of the actual popular vote, two-party popular vote total, from a forecast that is issued 3 months prior to the general election. So, with misses like in 2020, arguably 2000, in 2016 in a way, because Mrs. Clinton did not win the Electoral College vote. Forecasting can be a humbling experience, but as you can see, there's a scientific basis for forecasting, and we can use multiple regression model to get some very accurate forecasts of elections, such as U.S. presidential elections. Okay, again, a lot to take in, so let's just take a moment to breathe for a moment and refocus ourselves. Since I recorded this podcast during the summer, here's a summertime view of the Hudson River in upstate New York. This is the mighty Hudson River. This runs nearly 300 miles from north of Albany in the Adirondack Mountains at its source down past the Battery in New York City on its way to the Atlantic Ocean. I grew up very close to the Hudson River. This is around Kingston, New York, and I grew up just south of Kingston. So this is a familiar area to me. We would go kayaking on the river quite a bit. It's not that easy to navigate. The river looks wide and deep, but actually there are a lot of shoals around. So if you're going to pilot your boat through here, you want an experienced pilot with you to know where these shoals are. But it's a beautiful sight on a really gorgeous day along the river just north of Kingston, New York. To the right, you can't really see this, but off to the right would be the Catskill Mountains. And off to the left, the Taconic Mountains heading toward Connecticut. Take a moment to look. Thanks for watching this podcast, and have a nice day.